Hello everyone, welcome back to CloudOps Craft. Today we are going to discuss about Linux process management. Every running program on Linux. For example, processes are cars on a highway. Some are fast, some are stalled. We need to monitor, control, or terminate them safely. As a DevOps engineer, you will monitor resource usage, you will kill or reprioritize process, control background jobs, manage system service safely. So, to learn Linux process management, let's start with inspecting process. Inspecting process. Okay. So, for inspecting process, we will use PS. Okay. So, PS stands for process status. Okay. PS command shows processes running on your system. For example, if I am using PS AUX grep Nginx. Nginx is a web server. Okay. So here PS stands for process status. A indicates show processes of all users. So processes of all users. This U indicates show user and user or owner. X's include processes not attached to terminal. Okay. Here, why we are using grep? Grep we will use for filter. Okay. It will filter only lines containing nginx. Okay. So for this, we can install nginx. Okay. Nginx is a web server. So I have already installed nginx. Let me show you the command. Okay, first I have updated our server with the help of sudo apt update. After that, I just installed nginx sudo apt install nginx. So after installing nginx, I just executed this command ps aux -grep nginx that I have explained just now. So here you can see this output, right? Let me explain. Okay. First you need to understand all the columns. Okay, so only you can able to understand what is the purpose of each field. Okay. First is user, okay? Owner of the process. Here owner of the process is root. And second is PID. PID stands for process ID. Okay, it's a unique identifier. Your process ID is 3374. Next is CPU percentage. CPU usage of process is 0%. Next is memory percentage. Memory usage 1.2% of memory usage. Next is this belongs to uh, VSZ, virtual memory size in KB. Okay, which is 55,192. This is also in KB, which is resident memory, physical RAM. Okay, which is 11,776. And here, 1, 2, 3, 4, 5, 6, 7. 7 is TTY, terminal associated. Okay. Now you can see the question mark here, right? Which indicates damage. Next is process state. Okay. Here it is showing S for sleeping. Okay. Here you will get R. R means running. S for sleeping. Z equal to zombie. T equal to stopped. And D equal to uninterruptible. Okay. And this is start. Okay. When process started. 1328. This is time. Okay. CPU time consumed. And this is the command that started the process. So this is how this and all the details of process will show you. Think of each process as a worker in a factory. Okay? PID equal to worker ID, CPU percentage equal to how hard they are working right now. Start means what the worker is doing, active or resting or waiting. Here it is sleeping. Okay. So if you we will learn one by one. Next is p grip and PID of this we will use to find process IDs. So p grip and PID of, we will use this to find process IDs. Okay, sometimes you just need the PID of process. Okay, for example, if you type p grep hyphen fl nginx. Okay, so here F stands for match the full command line, not just the process name. Okay, match the full command line. L is there, right? L for show process name along with PID. Process name along with the PID. So let me execute this and we can check how we are getting an output. Okay, p grep hyphen f we are using to match the full command line, not just the process name. L for show progress name along with PID, and for nginx. Okay, now we are getting process ID with name. Okay, so if mostly we will need only PID. So with the help of p grep you can directly get the process ID and its name instead of getting all this info. Okay, so next is PID of PID. Okay, for example, if I type a PID of nginx, what will happen? It will return just the PIDs of the named process. Useful for scripts where you only need the PID to kill or monitor. Mostly we will use this for scripting. Okay, it will just print the process ID and it will kill it. Okay, so p grep is like you are asking who is doing this job. Okay, PID of is like you are asking give me their employee ID. Okay, now if you type p d PID PID of, let me do this, give it better, Genix. You can see it is only showing the process it. That is the one when you need to useful for scripts. Okay, where you only need the PID to kill or monitor. So next is that we are going to learn is PS tree. Any idea on this PS tree? Process hierarchy visualization. PS tree. Process hierarchy visualization. Okay. For example, if I type a PS3 hyphen P, okay, it will show process as a tree to visualize parent-child relationship. Okay. This P, what it will indicate? It will display PIDs. Okay. Useful to understand which process spanned others. Okay. So like a system D to Nginx, Nginx to worker process like that. Okay. So let's type this. Let's check PS3 hyphen P Nginx. So it is showing that no such username like that we are getting. So I'll just choose Ubuntu. You can see the tree. Okay. Imagine a family tree. Okay, parent, which is a process that sorted others. Child is like a spanned sub process. Okay. So next that we are going to learn is stop and yet stop. I hope you may know this, but still I'll explain because you need to know this options. Stop and yet stop. Real time monitoring. We will use this for real time monitoring. Okay. Stop command. Okay, it will display dynamic real time view of processes. It will show CPU, memory, uptime, and more. So here, like, let me execute this and I'll show you. If you type stop, you can see you'll get all these details. So here in common keyboard shortcuts is, for example, if you press K, it will be in action. If you press P, okay, P will be short by CPU usage. Okay, and M for short by memory usage. K for kill your process. C for full command line. Okay, so you can get all these details. Okay, it will display CPU, memory, uptime, okay, and all details that. Okay, even you can use stop. Okay, stop will be a more user friendly version of top, which is colorful and interactive, and you can navigate with arrows, skill process, short columns visually. Great for quick DevOps debugging. If you use stop, you can see the difference. It is so colorful, right? So you can use stop also. Stop and stop. Okay, it's like a live dashboard of a factory flow. It will show it showing which workers processes are busy, idle, or consuming most resource. For debugging, you can see which process is consuming too much memory or CPU. For monitoring, you can keep track of important services like Nginx, Docker, etc. based on your setup. Automation scripts can use pgrip or pidf to check if your service is running before restarting it. While coming to process management, you can use stop or stop. It helps decide which process to stop or prioritize. So next we are going to learn about killing processes signals. Any idea on this? If you have any idea, just pause the video and let me know in comment section. We are going to learn killing processes and signals. Okay. What is a signal? What is a signal? A signal is a tiny message the kernel delivers to a process. It's not data, just an instruction like a please exit or like a reload config or stop right now, like that. Okay. Common signals we will use is, well, coming to common signals that you need to know. First one is signal term term 15, which is like a polite stop. It's like a finish what you are doing and exit cleanly, like that it will tell. Okay, if you use signal kill signal kill, which is 9, okay, it is force stop, die immediately, which means cannot be caught or ignored. Next is signal signal up, which is 1, which is for reload. Okay, traditionally hang up. Okay, now commonly reload config for damage. Others, other signals also we will use. Okay, but these are the three we will frequently use. Okay, signal 15, 9, 1. Okay, these three things we will frequently use. Other than this, we will use I will let you know that also it will be useful for you in future. This three is frequently used. Apart from this, signal inter, which is 2. Okay, it is like a control C from terminal. Control the from terminal interactive stop. Okay, next is signal. This is 3. Okay, signal. It just we will use this to stop and core dump. Stop and core dump. For debugging we will use. Okay, core dump. Next is sig stop, or you can use sig continue. You can use this to pause and resume. Okay, like Control Z and FG. I will explain SG like FG also. Okay. Mostly we will use numbers only. Okay, kill -9. Okay, kill -1, kill -2, kill -3. Okay, like that only we will use. Okay. So widely used is this 3 1 15 9 1. Okay, 15 is like a polite stop, 9 is force stop, and 1 is reload. Okay, so common command toolboxes which each targets is: first is kill all, p kill, p grip. Okay, let me explain all this. First is, I come into command toolbox. First is kill. Kill is like send a signal to specific PIDs. Okay, it will send a signal to specific PIDs. Second is kill all. Kill all. We write this. Kill all. This is like a send a signal to process by name. Will send a signal to process by name. Next is pkill. It will send a signal to process match by pattern. Okay, processes matched by pattern. Okay, pattern, user, terminal, etc. Pgrip. It's a preview what kill could it. Okay, it will preview what pkill could it. It is like a safe or dry run. For example, okay, now we will learn the difference between polite stop versus forced stop. Okay? We learned, right, 15 is a polite stop, right? So I'll go here and I'll type okay, I'll type process type. Okay, now what we are going to do is, now we are going to do like polite stop means -15 and PID is 3377. Operation not terminated. It's use PS and it is showing. Okay. Kill what it will do, it will send a signal. -15 is a signal term which is polite. Okay, PID target processes 3377. The process get a chance to clean up. Okay, so like this is not permitted. I'll just use sudo. Now if I do to execute, as far as sudo spelling is wrong, you can see previously it was a 3377. I just killed it. Now it created a new process with 3378. Okay, so this is polite stop. Next we are going to learn force stop, which is kill. Again sudo kill -9 3378. Now if I do again process, it has been deleted and it is created a new process. iPhone 9 is a force, immediate termination, no cleanup. Okay, files can be left corrupt, sockets off, closed. Okay, use only if terminal doesn't work. Okay. So next is we learn about kill all, right? It will kill by name. Okay, you no need to use process. For example, I want to kill Nginx, then kill all next. Just use sudo. Again, it has been killed. Okay? So again, it is recreate like again it is newly created this process. Okay, so the thing is, it will send a term to all processes name engine. Okay, add a signal if needed. Okay, you can use kill all -9 engine. It is also dangerous, but usually avoid. Okay? On very old non-Linux Unix, okay, kill all meant kill everything on Linux. Okay? By its name. Okay, if your script crosses restores, prefer pkill plus pgrip, okay, for sanity checks. Okay, and you can even do you can kill by pattern also. You can kill the process by pattern. Okay, for example, if you are running any script, okay, you want to kill that main, then you can use pkill uh, under -f python manage.py run server. Okay, for example, this is the process you executed. Okay, then you can use pkill -f and you can provide that command. Okay, full command line. It will kill pkill. We will use kill to kill by pattern. -f is to match the full command line, not just the binary name. Okay, yeah, this is a pattern matches like the command that we have executed. Great when multiple Python processes runs on different tabs. Till now, is there any doubt? Next, we are going to learn about job control in shell. Okay? Job control. What is job control? Job control is the shell way of managing multiple processes interactively. Think of each process as you run as a car on a road. The foreground job is the car in your lane. You must deal with it correctly, it blocks you. The background jobs are cars on parallel lanes. They keep moving, but you don't need to tap at them all the time. You can pause, which is suspend, you resume in background or bring them back to foreground as you wish. With a few commands, you became the traffic cop managing all the cars, which is job. So before that, you need to learn about foreground versus background. Okay? Foreground, foreground job versus background job. Let's start with foreground, which is default one. For example, if I use a sleep, okay, 300, then what it will do? It will run for 300 seconds, just 5 minutes. Foreground means you can't use the terminal for anything else until it finishes or you interrupt it with Control C. Okay, so for example, now I am doing your sleep 300. Okay, so now I can't use this terminal, right? Until it finishes, I can't use this terminal. This only we will call as a foreground close. Okay? If you want to use the terminal, then you have to use Control C to terminate this. Okay, so only like we will use background job. Okay? So it will run in the background, so you can use the terminal. So while coming to background, you can use the same command like sleep 300. Additionally, you have to add and. Okay, this what it will do that trailing and tells the shell run it in the background. Now you will get your prompt back immediately. The jobs run okay in the background until it finishes. Okay? So for example, now I'll use background process sleep 300. So here one is the job number, and this is the process ID. So if you want to list jobs, okay, to listing jobs, you can use jobs. Okay. So it is showing one job is running, which is this 300, and okay, this one is the job number. This is the status. Status is running. The command that we have used, that is still running. So if you want to learn how to suspend and resume, like this is running in the background, right? This is running in the background. So if it is running in the foreground, then how we done? We used Control C, not Control C, Control Z. It suspends the job, puts in the stop state. Okay? So if you want to resume that, then you can resume with FG percentage 1. Okay, F for 4, G for ground, foreground. It will bring back to the foreground. Percentage 1 is the job number 1. Now the process is blocking your terminal again. Then how we can bring this back? This is running in the background, right? I want to bring in the foreground. Then what you can use is FG percentage 1. Okay. So now again the process is blocking our terminal again. Okay. So then what we have to do? Any idea? For example, if I use here BG percentage 1, again still it is running, right? So how to handle this? Now it is running. Just pause the video and let me know on the comment section how to again run it in background. So again I have to use Control Z. Now I use Control. Okay. Now it is stopped. Okay. Again you can use FG percentage 1. Again it will run. Again you can use Control Z. Okay, if it is in the foreground. Control Z. Now it is stopped. If you want to resume in background itself, then you can use BG percentage 1. Okay, now it is again started. Okay, again now you can check the status, you can use jobs. And now it is running. Okay, we just stopped it with the help of Control Z, but we have to run this in the background. Then simply use BG percentage 1. This percentage 1 indicates the job number. Here you can see the 1, right? So only I am using 1. Okay, so again I am running it in the background. So now we are going to learn persisting jobs after logout. Persisting job after logout. Okay, by default, if you log out, background jobs are killed. Okay, they get a sign up signal to make jobs survive logout. Okay. No up means no hang up. So you can use this. Okay, no okay, it ignores hang up signals. Keep running after logout. So and even you can use this one command also. This one you can use percentage 1. Okay. It removes the job from the shell's job table. The job keeps running, but the shell forgets about it. Useful if you already started a job and then decide you don't want it killed on logout. Okay. Then you can use this one percentage 1. Okay. If you have any doubt, message like let me know on the comments. Next we are going to learn is Reprioritize process. This is also important. Reprioritize processes. And here we are going to learn concept called niceness. Niceness means nice value is a super user space int to the Linux scheduler about how nice a process should be to others when comparing for CPU percent. Here we have some range. Okay, range if minus 20 is highest priority. Okay, and default is 0. Okay. Lowest priority. Lowest priority will be minus plus 19. Higher nice is equal to process L CPU more willingly. Okay, gets less CPU share. Only root means only root can get set a negative example increase priority. Okay. Regular users can only increase niceness, make their process run with lower priority. Imagine several cooks in a kitchen. The head chef, which is minus 20, gets the first AIBs on burners. Junior cook, consider plus 9. Only cooks when burners are free. Niceness says how polite a cook is about, okay, it's all about burners. So here, we will practically learn this, so you will get some idea. Nice. Nice is a start command with a nice value. So syntax recommended explicitly is nice hyphen n. You have to use capital N at the command arguments. Okay. For example, I am using nice hyphen n 10 dot ab hyphen job dot sh. Okay. It's just my sh file. Self this nice, it's a utility to sort a process with adjusted niceness. Hyphen n10 is set the process nice value to 10, lowest lower priority than default 0. This is the command you want to run. Okay, and this the run the command in the background so the shell is free immediately. What this does in practice, for example, every hyphen job.sh will run. Okay, but the scheduler will give it less CPU relative to process with lower nice value. For example, your web servers processes at nice 0. This is useful to let background batch jobs runs without interfering with interactive or latency sensitive services. Okay? It's best to always specify hyphen n explicitly to avoid any issues. Okay? You can provide the priority. Some systems default nice without options an increment. So so for example, I have some script. Okay, so consider I'll write one script. AV job dot search. Here I am just typing what we can type. Like I'll just execute one command. Okay, ps kux script, just a normal Linux command. Now I'll execute this command. Onion AV search. Awesome. Execute this with sudo. Why we are getting permission issue? Yeah. If I type pwd is no Ubuntu, okay, and you can see this. Then why we are getting permission? Use -. You can see the permission. The execute permission I don't have. So I'll use this is for just for testing it. I'll provide 777 permission. For owner, I'll give full permission. for read and execute same permission. Just 7 read 4 plus write 2. 7 and write is 4, right? 7 6 maybe. Again I'll run this. Okay. Now it is showing that command output. Okay. So this is how we have to run with parity. Okay. Renex. Next is Renex. Renex. It will change the nice value of your running process. Okay. For example, if I'm using sudo renice -n -5 -p 2345, what it indicates, this sudo is you need a root to set negative value, negative nice, okay, which is -5. Ordinary users cannot. A renice is a tool to change the nice value of an already running process. Okay. -n like -5. It will set the process nice value to 5, which is higher priority. P2345 is the process ID. Identify the target by PID, which is the PID. 2345 is the PID. Okay. After running this, PID 234 will be scheduled more aggressively than it was before, unless its nice value was already greater than or equal to minus. Okay. Like this, you can use. You can ask how niceness affects scheduling. Okay. Modern Linux uses CFS, completely fair scheduler. It maps the nice values to scheduling weights. Higher priority processors, which is lower nice, gets a larger share of CPU time to relative to lower priority process. Okay, for example, if you are running any script which needs more CPU, then you can go with nice. Rarely we will use, okay, if you are running any script and if you need more CPU, then we will get that with the help of nice with priorities. Okay. So higher higher priority process, which is lower nice, right, get a larger share of CPU time relative to lower priority process. Important is nice changes or relative fairness adjustment, not absolute CPU guarantees. A high priority process on a fully loaded system still completes with other higher priority process. Niceness changes the ratio of CPU time the kernel distributes. Okay, niceness is good for cooperative CPU share control, okay, for batch jobs versus interactive service, but not for odd QoS characters. Okay? For strict CPU limits and isolation, you can go with the C groups and CPU sets. Okay, mostly it will be used by Linux administrator with these commands and all. As a DevOps engineer, rarely we will use nice. So if you like this breakdown, subscribe to Cloud Ops Crack. We will simplify cloud and DevOps concept every week. Okay? Thank you.